integration of exponential functions. So yesterday we looked at differentiation. We looked at differentiating by first principle a general exponent. So it might be 2 to the power of x or 3 to the power of x. Okay, so that's how you need to differentiate that, although I'll be surprised if that comes up any further after your textbook exercises. I don't anticipate I'll be asking you guys to do that unless I'm asking you specifically a differentiation by first principles question. Alright, so we differentiated that. So yesterday we covered that dx of e to the power of x. It's the same, alright, e to the power of x. Right, that works because the value for e, which is approximately equal to 2.72, right, that gives you the gradient function exactly the same as the original function. Okay, that's why that value was picked. Right, so if we're going to integrate e to the x with respect to x, we differentiate e to the x, we get e to the x. Right, so when we integrate e to the x, what's the answer going to be? E to the x and Charlie to the integral party. You can go and ask at the staff room, Amanda. You know where the staff room is, don't you? You can go ask at the staff room. Hi, breathing. My name's Mr. Lee. I was supposed to only be 32 today, actually. So that's right. Alright, so the integral of e to some function of x, dx. Okay, it's very similar when we integrate your powers. Right, so it's going to be 1 over f of x, e to the f of x. That doesn't solve yeah, I was going to write that in the book. I'll do that soon. So 1 over the first derivative. Alright, so you do need to do some differentiation before in part of your integration. So the first derivative on the bottom. Say what? Alright, so that's your rule. Okay, don't forget your constant when you've got an indefinite integral, and that is also on your formula sheet, okay? On your reference sheet now, sorry. So you have that too. Alright, let's do the first couple of questions here. Alright, so I want you to integrate the following. The integral of e to the 2x dx, and the definite integral from 3 to 1 of 2 e to the x in exact form. Alright, can you do those two questions for me?
It's going to be hot now, man. I do for everyone.
It's a small bit painful. Right, so you're going to use your rule. Okay, so when integrating e to some function of x other than the coefficient of 1, okay, this will always be linear. Okay, I won't be assuming anything else other than linear for the power. Alright, but it would theoretically still work, I assume. Can't remember. Anyway, we don't expect 4 linear functions in the power. So you need to differentiate the power, that goes on the bottom of the fraction. E to the power of 2x, the power stays the same, and because it's an indefinite integral, we need to add that constant integration. The thing about it, when you differentiate, you're going to bring that 2 down, be 2 over 2e, and that stays the same, and differentiate a constant at 0. So it'll be 2 over 2 simplifies to 1, which is the same as what you've just integrated. That's how you can check your integration. You differentiate it again, and you should get the answer as what you try to integrate. Alright, the second one, that in exact form. Alright, so we got e to the x, alright, so it will stay the same. And because you've got the constant of 2 out the front, alright, we'll also include that too. Alright, I wouldn't bother having 2's now, just factor over anything out as I can. Alright, so 2 outside of e to the power 3, take away e to the power 1. Alright, and that's the exact form. We can't do any further than that because that will give you approximations on your calculator from there.
Oh, why would you do that? I don't know. Why would you do that? You asshole. I'm sorry.
Bromance.
Oh, why? I'm so sorry. Jesus Christ. Why would you do that?
It's fiddling with his eye and then closes it.
Part of me thinks he deserved it. Alright, so obviously the application integration is to find the area and volume, so we're going to have a look at that. Right, so we need to find the exact area between the curve y is e to the power of 4x, x-axis, and the lines x equals 0, x equals 5. Alright, so you're integrating about the x-axis, that's the one where you need y the subject. Right, this will be your main one, but you've got to be careful when you're integrating with respect to the y-axis, you need x, the subject of your equation. Alright, so if you've forgotten that, you need to go back over your integration notes. Alright, so everything's all set up, ready to go. We're going to integrate e to the power of the area with respect to x from 5 to 0. So what is the integral of e to the power of 4x? Using the rule?
1 over 4.
Yep. Okay, so the power stays the same when you have exponentials from 5 to 0. So it's going to be a quarter. E to the 20, and then e to the power of 0 is 1. Okay? And you can't do any more with that. And don't forget your units when you're finding area.
Right. Where did the X go?
So,
Where did the X go?
X is 5 and 0.
when you substitute that and that for x to evaluate definite integral. Alright, last one, and then you're going to have some time to work. So the volume revolution formed when the curve y equals e to the x is rotated about the x-axis from x equals 1 and x equals 4. Okay, the volume now. Right, what was the formula for volume? Pi. From B to A of, when we're about the x-axis, we need what, the subject?
Y.
Just y? What's the formula for the area of the circle? Pi squared. So when you're rotating that area, you're rotating about the axis, so your radius is the y value, you need to square it. Okay? Because when you rotate, you are forming circles, you're stacking those circles on top of each other to find the volume. So when you do the volume, you need to have pi y squared with respect to x. Okay, so y is e to the power of x, y squared is e to the power of x all squared. So what's the next line looking like?
E to
Okay, use your index laws, e to the power of 2x. Okay, you need to know this. This will be in your assessment, not exponentials, but the general principle of volumes. Areas, volumes of your functions. Okay, so pi integral from the bounds 4 to 1 of e to the power of 2x dx. Okay, so pi over 2 e to the 2x, because I need to differentiate because I've got a coefficient other than 1, and I've just brought that out the very front to have an effective form, because that 2 will be over each of those two terms, each of the terms, when you do the subtraction inside the bracket. From there. Right, and that's our exact form. We can't do any further than that unless we've been told to approximate to a certain number of decimal places. Unless you're told that, you need to leave them in the exact simplified form. Okay, and don't forget your units cubed for volume. Right, so the past couple of lessons in differentiation and integration of exponential functions is now up to and including exercise 4.3 in your text. I am done.